if you did this guy, the 13.1 notes, you find these 13.2 notes for these word problems are a little bit different, all right? A is still our for exponential decay function, right? We used to have 1 plus r. Anytime your ratio is more than 1, it's exponential growth. Less than 1, exponential decay, right? Kind of what we're witnessing, stuff going down, right? So we have the start, the amount of decay, and time, and basically that's it, right? So decay rate is a constant percent decrease, r in decimal form, and let's write this out, all right? Given each description of decay, write the exponent decay function in this form and graph it on a calculator. So we have, let's say, f of time, and we'll fill everything in. We'll find our start first. A truck was purchased for $28,000. Well, there's our start. We started at $28,000. All right, decreased by 9.5 each year, so 1 minus 0.095%. All right, each year to the t. Don't leave it like that. We could write whatever that is, 90.5%, 0.09, right? 0.905. But I'm going to leave it like this for right now. That's what it gave us. And then we wrote the exponential function. And we're going to see our goal. So let's write g of t, maybe, is going to be to see how long it takes, predict how many years the value will go to 5,000. And that's all we need. Kind of easy. I've already graphed these in the graphing calculator, and obviously I picked an awful window, but there is my graph, right? There's our 5,000. There is our, let's go down one, and you can see our function with the decay rate to the x power. So, I would like to at least be able to see that 28,000, which that does it. Let's just maybe even shrink it down a little bit. We'll maybe go to 30,000 so we can watch this thing decay a little better. And let's make our x max, those are the years. I don't know, let's go to 16 and see if that shows up. So there's our 5,000 goal. Ooh, well, it might not get there in 16 years. Look at that. I'm going to have to add some more years, aren't I? Those haven't really met up, although they look super close. So I'm going to go to 20 and we'll graph it one more time, and hopefully this will show up now. And I think we're going to get a crossing here. Right there we can see a cross. So second calc, intersect. And honestly, this is just getting as close as we can and hitting enter 3 times. So I think they intersect somewhere around there. I'm going to hit enter, enter, enter. And it looks like after 17.25 years, I'll show you again, it's right down here, the x value, they cross at 5,000. So I'm going to say 17.25 years. And that's it. The next one builds off of this, and let's see if I can find it. It's over here. Alright. So the value of a sports car starts at 45,000. So let's write g of t. There's our start, right? It's 45,000. Decreases by 15%. I got two things. I could write 1 minus 0.15 like that. I'm just going to cross that out and go 0.85, which means I keep 85% of my value each year. I lose 15 per year. Write an exponential function of the sports car, plot it along with the previous example. So let's do that. We got this. So we got one in there, right? And let's plot that one. We had 45,000 times, what was it, 0.85. We lost 15% a year to the x power. And then we graph them together. Let's see if this is a good, wow. There's one of them. I'm kind of not seeing this. Here we go. 45,000 is higher than that. Decrease. Oh, you know what I did? I didn't put it to the x power, did I? So let's do that. To the x power. Let's see if this graph looks a little bit better. There's one of them. It's probably the 45,000 because I don't think I went up high enough to get 45, but I did go up high enough to get that crossing. So we can see where they're crossing. So this one started at 45, decreased at 85%, or 15%, kept 85%. And that was our original graph. So let's calculate when they intersect. So we'll get to about where they intersect, somewhere in there, I believe, maybe there. We'll hit enter 3 times, guess. It looks like it took them about 7.6 years, approximately. 7.6 years. Alright. Sports car example B. Calculate the average rate of change over the course of the first year and the second year of ownership. Alright, we can do that. What happens to the absolute value of the rate of change from the first interval to the second? What does this mean? Well, let's do it. That means we're going to have to go from 0, 45,000 to 1 something, and then again to 2 years and something. So, I don't know. Let's use our table. So I'm going to go second table set, put it on ask, and then it can give us our answers when we plug in 1. So here's 1. Looks like, you know what, let's go ahead, we don't need this guy anymore, let's delete it. We're going to clear that guy out. Now we'll go back to the table. It looks like 38,250. So 38,250 after the first year. Let's go ahead and get the slope. So slope is y1, 45000 minus y2, 38,250, and 0 minus 1, right? Alright, yeah, so let's see, y sub 2 minus y sub 1, x sub 2 minus x sub 1. Alright, so it looks like we get a, what's that, 0. Let's just do it here real quick. It's a little late. So I'll say 45,000 minus, what do we say, 38,250. 38,250. And I get 6,750. So, and since the bottom has a negative, right, -1, we have gone down $6,750. So, let's do this next slope. And we can probably see that it's not going to drop as far because we're doing percentages, but let's check it out anyway. So if I plug in a 2, 32513. So 32513, which is y sub 2. Let's go the other way. Let's go 32513 minus 38250. It really doesn't matter the order that you put this in, and then 2 minus 1. Just going to get a negative on the top instead of the bottom. Ooh, let me move this up. Alright, just like that. And I'm going to subtract it over here. So, 38250 minus, just using my calculator, 32513. This gives me -5737 over 1. So what we can see is that it increased by almost 7,000. It almost dropped 1,000, right? So what does this mean to this situation? What happens to the absolute value of the rate of change? Well, this guy, if I made it positive, that would be 6,500. 6,750. This would be 57,000. So it's dropping. The rate of change decreases. Well, let's just look at this visually, right? We can see that if I have a graph that kind of looks like this, eventually it's going to level out, and it starts to do this huge decrease in the beginning, but then kind of levels off. So my rate of change is going to decrease as years increase. Let's see if that answered all that. What does that mean to the situation? Well, that's what it means. As the years increase, rate of change will decrease. We'll leave this C for you guys. Try it out. Same kind of stuff. It should be a quick, easy problem. And I'll check this for you tomorrow. You guys have a good one.